logic will be shown. I got one chance to show you what I got. I got one chance to show I'm confident or not. Self-evident reason, deductions and conclusions, and the fools are running away. It's not what you say, it's only what you can prove. You better watch your step, you better mind your P's and Q's. You got one chance, show me what you got. You got one chance, show you confident or not. Don't get caught in the matrix of all of these fakers. Society's spinning, and I'm just here living on the ground. Self-evident reason, deductions and conclusions, logically thinking, and the fools are running away. You're flipping over backwards to show me where you think you are. Your model dictates that you never see too far. Shrinking in the distance, you can do fuck all with an angle, and the fools are running away.
What is horizontal? When you're standing in one spot and you use a water level with a little bubble in it, that's due to curvature. It has to be.
Right, okay. A bit of a weird encounter with Sean G this morning. Spot on comment to, I don't know, somebody. Just so happens that if water is at rest, it will establish an even altitude or level known as a plane or water level. Sean G, and what is that level in reference to? Because when talking curvature, elevation gain or drop and measured curvature aren't the same thing, and level is referenced on globe model. And the level replies there. In the UK we have all elevations measured to the mean sea level at Newlyn. That's all, as in the entire UK. That's one datum for every position anywhere in the UK. You think the surface of a sphere, the bit you see when you look at, is 2D or 3D? Random. Probably come from last night. We were talking to a 2D earther. Can somebody... Sean G, are you sure the OS only one, and even so it's also check with other datum points too? Just see if I can swap this over. I can cut it out anyway. There you go. Transition. Get it over. This is UK National Tide. Can you see that? That's better. The tidal observatory was established to determine the mean sea level, that is the starting point for levelling in the UK. This brass bolt is the benchmark for the whole of the United Kingdom. That is, all heights are referenced to this point. The height of the benchmark was established over a 6-year period from 1915 to 1921, where visual observations of water level tide on a tide staff were made by every 15 minutes for 6 years. Even the equipment that we did it. And there's the geodetic map of the entire UK, all referenced to this one point. This map shows the extent of the levelling which took place in the UK during the first half of the 20th century, starting at Newlyn and working its way to every corner of England, Wales and Scotland. This process was all done manually using land levelling equipment. From this primary network, secondary benchmarks are set up, and these are used in turn to level in the tide gauge pressure points, thereby referencing all tidal monitoring points to the same datum and each other. So yeah, just to let Sean know, and he said I said all others are referencing that one datum in the entire UK. How are your datums referenced in the US? And he put, with numerous datum points and existing points plotted throughout America. No capital, that's it. Referenced from the 3 original points. In my local area there are 3 original points of it. I don't know. And so I asked him, 3 coplanar points. We have datums everywhere, we call them benchmarks, but they're all referenced to that one in Newlyn. You only have 3. Are you talking about satellites or datums? And he puts datum points, surveyed points. Benchmark is a point surveyed from a 0 point. Okay, in my 60 square mile area, it's a square mile, remember, there are 3 survey datum points to reference. There are thousands of benchmarks to reference. And the plane you refer to in surveying in UK is not surveying for curvature. And the plane you refer to in surveying in UK is not surveying for curvature. It's topography mapping, property layouts, such a small area surveying. I mean, I know we're only a little country, but that's does say the entire UK in the datum thing. I'm going off what it said. And I put, now it's the datum they used in the last survey of the UK. All elevations throughout the whole of the United Kingdom are referenced to it. It's a matter of historical record, as I've just read. But yeah, that's correct. I was only commenting on you saying the term plane surveying. plane surveying. I don't know. I didn't spot on put plane there, and then I 3 coplanar points because he put 3 datum points. Datum. He may have misread it. 3 non-collinear points are coplanar. That's a mathematical fact. Is that what triggered you into your plane surveying rant? Lol, probably. I clearly misread it. I apologise. Oh, that's nice. But you do realise all surveying tools are for plane surveying, right? You know, auto levels and theodolites. Even GPS. He's put yes. You do realise that all surveying tools are for plane surveying, right? Yes. Yes, and when used correctly, can be used to measure curvature. Well, they do. The elevation changes. Or reference to a vertical datum. So when used correctly, can be used to measure curvature, and with benchmarks over 100 plus miles is no longer plane surveying, it geodetic. Well, if you measure with planar tools up to 100 miles, keep referencing it back to the same point and other points to keep everything checking back on itself. Triangulation. Geodetic must just be a term. But yes, survey equipment is. It's the application of data over distance that classifies between plane and geodetic. Oh, it's just the data, the application of data. It's the application of data that's the difference between plane surveying and geodetic. I do surveying, I understand the basics, uses and terms well. It's gone to the really bad English and the bad grammar. I'm not too keen on that. And then he had to go to bed. I said bye, and then I read over what he said and decided to record this. So the benchmarks established within are planar. Once you get without 100, they stop being planar for some reason. Try a bit of logic.
Again,
Any distance.
And I just explained the steps to checking to see if that is the case. And Irtia, and this is a very prime example of why I'm even here talking. You keep stating things as if you've surveyed them, when in reality you've only done grade check.
We know how water flows, sir.
Yes, we do, 100%. And we understand that the elevation has to be lower for that water to flow to the next lock.
If you fill the water up to the top of each lock, if you lower one lock 1 inch, the water is gonna flow out that 1 inch until it's 1 inch lower of the other lock.
Of the dirt, that does matter.
No, it has nothing to do with the dirt underneath.
Okay, then why are they constructed? Why
What are you
there-
talking about?
Why is there a top and there's a bottom of a canal?
Brother, I don't even know why you're even. Are you serious about this?
Yes,
Hang on.
yes, I'm very
I
serious.
feel like
about
I
it.
need to ask him a question all of a sudden. It's good to talk to a surveyor, Sean. I wanted to just ask you one quick question, though. Have you used an auto level?
Yes, many of times.
Okay, so, you can go 50-meter increments, whatever, with an auto level. Okay, one quick question. If you survey out a mile in your 50-meter increments with an auto level, over that mile, you measure an 8-inch drop. Would you call that an elevation change or earth curvature?
Elevation change.
Hmm.
Now you can
Cool.
create a mean line to check for curvature, but we're just doing in the steps you said, that is elevation change. That is not curvature.
So based on that horizontal that you established over that mile, you can measure that 8-inch vertical change from that horizontal, and that is an elevation change.
It's an elevation change until you set up a controlled mean line to establish curvature.
Whoa, wait a minute now. Control mean line to establish curvature that you did not measure within that mile?
No, when you're doing that controlled distance like a mile, and especially in increments, all you're going to be checking is the elevation to start. You would then have to set up a mean
Okay.
line. In that mean line, you would observe off your control line, and you would then establish curvature from that. But what you just explained is only one step, and that one step with an auto level is just grade checking. That's elevation changes.
Can I
So
ask,
elevation.
Sean?
Yeah, go ahead.
We've got a canal of 27 miles. Leeds to Liverpool. There's one section in between locks, 27 miles. What grade would you say that's got?
I'd have to do the same thing. To establish you establish 20 points, and after you've established the elevations, you would create a control mean line, and then you could establish whether or not there's curvature on that. But otherwise, again, all you're talking about with an auto level is just doing your elevations.
It would be the canal. The canal, it's not an auto level, it's just the canal.
I understand that, but to do what you're asking, you would use a tool, and in those tools, say an auto level is only one step to figuring out what you're looking at, and all that's going to give you is the elevation changes.
Could you use a water level?
If you had one long enough, or you wanted to set up with that many control points, absolutely can. It's the same thing that's the same thing as an eye level site, same thing as an auto level. All you're doing is the same thing.
So wouldn't the static water in the canal be the water level?
Are you going to put your tool right on the water level, and then establish points along that ocean? Yeah, if you did that, or that canal, then yeah, that would work.
No, I'm saying you could dig a ditch 10 foot tall, put locks on either end, dam it up. You could put whatever grade you want in the bottom of that ditch.
Okay, that's what you're
One
saying.
end could be 10 foot, one end could be 15 foot.
Yep.
Put a set benchmark at one end at 5 foot. Put the other end at build a dam at the other end at 5 foot. Fill it up with water, and guess what? It's going to be 5 foot above the bottom of the. It's going to be 5 foot minus the grade.
And that's all.
It's going to be 5 foot at one end and 15 foot at the other.
Okay, so what basically you just said is, if we're talking just the level of the water, and we put a control point every 20 feet. Every 20 feet, if the water's static, that water level or that elevation is going to be 0, and I'm gonna get 0 all the way to that next lock.
So horizontal.
The issue is once you've done that, and then you set a control mean line, then you would see that there is curvature. Again, just doing
that doesn't make any sense, brother.
What's a mean line? Would it be mean by adding up all of the different elevations to find a mean line? So you would end up with a 0, wouldn't you?
No, you wouldn't. You wouldn't, because that's again. So what you're saying is we take the elevation every 20 feet on the water. I am answering your question. I'm answering it because, again, to understand what I'm talking about, you have had to either done it or you have to completely understand what I'm saying. Because when you set up a control, so when you set up a control mean line,
Sean, please answer the fucking question. Are you assuming I haven't done it?
Oh no, I'm saying in general. I'm not saying anything actually to what you have done. I'm saying this is how it's done, regardless of how you think it's done or say it's done. I'm saying how I know it to be done and how I've done it and it's worked. So when you're setting up, when you've done those elevations, you got 0 on the water all the way to the next lock. You set up that control mean line. You're not setting up a control mean line that you're checking every 20 feet. You're setting a 10-foot hike up, and you're going to shoot to the next lock. You may have to have reflectors in between because you can't see 27 miles. But when you're doing that, you're not setting.
Reflectors? Fuck off, Sean.
Wait.
Who the fuck are you
wait a minute. So you're telling me when you do surveying, you don't use reflectors so your total station can receive data from that point?
John, I don't use a total station.
Okay, so then again, don't tell me I'm a fucking idiot or I don't know what I'm talking about if you haven't used it, because I'm trying to explain how in a situation you would do these things.
You're trying to tell us what the mean line is on a canal that stretches 27 miles with a 0 elevation change all the way along it. A measured 0 elevation change.
Yep. Yes, I am.
So what's the mean line then, Sean?
The mean line is, again, I'll start over. When you set it up, you set it up like a 10-foot hike up so you know you're not going to run into the water again or whatever. So the mean line isn't dictated on the elevation of the water. The mean line is dictated on the hike up you have on each side.
What do you mean a hike up? Explain a hike up, please, Sean.
Because you're not putting your face, your eye level, or your measurement tools on the water level itself, you have to do a hike up. So a hike up is if the tool you're using stands 6.5 feet above 0, then you have to use that as a hike up. You have to calculate that in your elevations. So that way, when you shoot a distance and you get 6.5 feet above elevation.
Stop. Let me read this from some surveying books.
Why am I, Rikia? I was in the middle of my sentence. So why?
Yeah, we heard you. We heard your mean line explanation. I believe it.
That's fine.
I trust you.
I got into one step of it, and you cut me off. To read something. Okay.
So say we're trusting you. I'm going to read the definition of a mean line from a surveying book. You ready? Absolutely. Have you ever read it?
Oh, no, Ricky. I have no clue. Go ahead.
Okay, so in typography, the mean line is the imaginary line at the top of the X height. Round glyphs will break the mean line slightly in many typefaces. I can't say that word.
Yep, exactly.
Since this is aesthetically more pleasing, a rounded shape will appear visually smaller than the flat top shapes of equal height due to an optical illusion.
Yes, and that is why, and Bev has said this is same as I have, and I think you may have even, I don't know if you did or not, but when we were talking about, like, say, the 27 miles, why you would do points in between every 20 feet, 50, 100, whatever. That's why you would have to do that, because over that whole distance, you can't shoot from one spot to 27 miles in one shot. What you're reading is explaining you can't do that.
They don't do it over water, Sean. They do it over land. Because they know the water doesn't deviate.
Do you know what dredging is?
Oh my God, bro! You're talking about the bottom.
Yeah. Do you know what
dredging is?
And the water level matters when you're doing dredging because of time.
Doesn't affect the top of static water, Sean, ever.
Okay. Again, when you're doing it that way, if you're going to set up a control mean line, it's not to the elevation at which you're shooting. It's a control line. You mean an
imaginary line affected by an optical illusion?
Yes.
They don't do that for water, Sean.
Yes, they do.
They do it. Oh no, they do not.
Wait, Rakia. How can they tell what high tide and low tide is? You understand that there isn't a sea level.
God. We're talking about
there's no tides on canals.
Static water, Sean. Static canal water, Sean. Static.
Talking about static water.
You keep going to oceans and tidal water. Static.
Hang on, let's not all talk at once.
Non-deviating.
Rakia, if you're
I'm done with this guy. Wizardry.
Good dad. Good.
Yeah. See you later.
You became a headache anyway.
Right, because I'm talking about static water, and you're talking about tidal and dredging.
Beth, I'll come back in when Priya's gone.
Look, have a look in the live chat there, Sean. There's a little drawing I've done. You can pretend the water level's in a canal if you want. And then there's 2 tools there called water levels. Can you see him?
They have dropped out.
No, he's here. He's still here.
Yeah.
I'd like to ask Sean a question, if I may.
He's feeling a bit edgy at the minute.
All right, when everybody cools down.
Yeah. Give him a chance to calm down. He'll be right. He might be reading some books.
You know what I was wondering? I was wondering this. If we can establish, let's say we can establish a canal and establish that it's, let's say, 6 miles long, and we have locks at either end. I was wondering if that's sufficient for Sean to start a discussion.
He's gone.
Yeah, that's what we were talking about, the canal, but he kept moving to dredging ocean tides and stuff.
What up? How you doing?
How you doing, mate? You good?
Yep, doing real good.
Yeah, excellent. So you're going to explain how you measure curvature using an auto level, yeah?
Oh, using an auto level in the setup of measuring curvature, it'd be just one tool that you would use in that.
An auto level. That's what you said in the chat. I asked you, how do you measure curvature using an auto level? And you said, I know how to use one and how it applies to using to measure curvature.
Yeah, it would just be one more tool that you would use in the measurement of the curvature of the Earth. It's
So
not a
it's-
single,
so
not a single tool that you use.
You said you know how to use one and how it applies. So explain. On you go. The floor is yours.
Okay. Well, first you could use an auto level to measure the elevation at which you're at, and then in using that, you have the set point. Then you use the theodolite to measure, or I would actually use my tool station first to.
Hang on. We're talking auto levels.
Yeah, but I've also explained that an auto level isn't a single tool you use to measure curvature. I said how it applies to measuring curvature in the fact that it's one tool that you use.
So you can't measure curvature
no.
using an auto level.
If you have just an auto level, no.
Right.
No.
Okey-dokey.
An auto level is something you use to check elevation changes. But as a single tool, no, you can't.
Because you establish a horizontal plane and then measure a vertical drop or rise in elevation from that.
And an auto level isn't accurate enough and can't do it. It doesn't do what you need it to do to get measurements for curvature. All you're going to do is get elevations from that single tool.
Okay. And there is no way that elevation change can be construed as being curvature, no?
Not with that single tool.
Okay. So I just wanted to clear that little bit up about the auto level, that it is a planar tool. And so on you go with the rest of your explanation.
Absolutely, you're 100% correct. With an auto level, single tool, you cannot use it to measure. You can't measure curvature with that single tool. It's just one tool that is applied with other aspects of it.
Okey-dokey. Floor's yours.
Okay. Actually, let me find a picture real quick. It'll be better to explain exactly how to do it.
Take your time.
Crack out the guitar and sing us a song while we're waiting.
Yeah, basta. Come on. Live premiere.
I wish I
This isn't
could.
exactly the image I was looking for. Basically, just will give just what I'm saying.
Sorry?
The picture I just put in the chat thread. Should I put it? I should put it in the other one, huh?
No, chapter is fine. What's the significance with the picture?
It's just reference point. So at where I'm at now in that image, I'm at 5,000 feet. And say, so I want to measure if there's curvature or if it's just elevation change to that mountain in the distance. So with my total station, I'm going to check my elevation on where I'm at and the height of my tripod. That even that mountain in between the two mountains, in between myself and a far mountain, I'd even check the elevation on that with my total station. And then the same for that distant mountain. Now, in that, all I've done is put data point and found my elevations for those, correct?
Well, if that's what you say you're doing.
Okay, I just wanted to make sure.
I
everyone's the same
say,
page.
like, are you going downwards? Are you setting your
absolutely.
elevation, your data
my elevation
at the highest point?
Yeah, I'm going to check mine for my elevation, and then I'm going to compare. I'm going to
How
make
did-
that at one point.
How did you get that initial data at the top of the mountain that you're at? How did you get that one?
If I'm just doing a basic one and I'm just checking for that reference, I'm probably going to use a GPS locator. I'm sorry, and that will give me my elevation, and that would be the simplest way of doing it. But if I wanted to get really accurate, I would probably look for a datum point in that vicinity, and I could, go from there and check elevations till I got to the point where I wanted to make the observation.
So the datum point that you would preferably find would be a first order measurement.
That's going to be that would be perfect. Just nothing can get better than starting at a datum point.
Yeah, first order, right? One that's been measured.
Yeah, and if that, and like I said, if I needed a reference to that, I'll use GPS to check it and check my other elevations as well.
Okay, so would you then presume you're going to use that one that you've either got by a datum point or whatever to go and check another mountain that probably already has a datum point on it? Right?
Well, their datum points are pretty big, far from. They're not within a mile of each other. But I would only need to reference that elevation to one location, and that would be my start. So if I get to where I'm observing these mountains from, and I get the elevation to that point, I no longer have to reference that datum. That's my spot. And then if I know I'm coming back to it, I'll mark that spot, mark the height of my tripod instrument, and that would become my datum point.
Yeah, you sound like you do this quite a lot.
I do topo maps, property lines.
What's the purpose of this mountain to mountain thing? Why would you be doing that?
This right here, I didn't survey. This is just an observation I had made. Took a picture. I thought it was a good picture. I'm just using it as a reference to how I would do it. But if I'm just on a weekend want to show that there's curvature, this would be a location I would go to, and then I'm kind of just going through the steps of what I would be doing.
Go
Perfect.
Up a mountain.
Yeah. Well, it's the easiest to have a further reference frame, so you can have different locations.
But when you say you would be showing curvature, what exactly do you presume you're showing? I can see a load of clouds and I can see another peak of a mountain, but other peak of the mountain will already have had a first order measurement taken for that, wouldn't it? Or is that what you?
Yeah, you're right. You're 100% right.
Because you're not doing first order, are you?
I can. I was just explaining how I could do first order.
Oh,
Otherwise,
you
yeah,
could.
that's another way to
You
do
could
it.
do
Yeah, I
first
could-
order measurements from one mountain to another.
Oh, absolutely.
Go on. For what purpose?
That to create data topo map. I've done numerous topo maps for different locations. That's exactly how we do it. I would get data. I would basically all those mountaintops you see, halfway down those mountains, the lowest point of a valley. I'm gonna get shots everywhere there. I may even take the first valley between me and that first mountain. I could take 1,000 shots just if I'm doing a topo map. So I mean, I can establish elevation from a location as well as
topographic.
go to a GPS. Yeah, I can, for like what you're saying, I can go on a GPS map and find out what the elevations of each of those peaks are, and that would cut off a lot of work. But at the same time, I'm kind of just going step by step through how I develop a topo map.
Yeah, they say they're already been measured, haven't they? It's not, you're not measuring uncharted land. It's already been charted, hasn't it?
GPS wise, yes. But at the same time, so here's a better way of saying it. I can start from where I'm observing from. I can mark that data point at 0.
Yeah.
So then every shot I take from that 0, my numbers would be referenced from 0. It wouldn't be referenced from the 5,000 feet I'm sitting in.
Yeah, you
So
just
in a
do it
sense,
from
yes,
a
I
known
can-
elevation. We do know how this datum's
Well,
marked.
whether it's a data point or a GPS telling me my elevation, it's still a reference point. But from that 0, 1,000 feet lower, 1,000 feet higher, I can establish with my tools. I don't need to know the different elevations of those mountains. I can establish that with my tools.
Yeah. And you just measure a change in elevation. A vertical change.
One aspect of it, if I'm just doing a topography map, yes, I'm just looking for elevation.
Okay, so what we're after is, I think you came in here to show us how you measure curvature. Now, we all know, before you continue, we all know that the slope of a mountain, that's curve, right? That's what you're talking about, right?
Absolutely not.
No.
Like I said,
what are you talking about when you say you
talk
can measure
about
curvature?
The auto level to the total station topography are just more steps the steps you take to establish curvature through another step that you would have to do.
Yeah, but that's the curvature that you're measuring, right? The land, the curvature of the mountain as it rises up and then drops back down again. Reference to a vertical, yeah?
Yeah, and that's just one step of it. That's not the final step to measure curvature, but those are necessary steps to measuring curvature.
What? Measuring a distance and how much it rises.
Yep, elevation change and distance. Yep.
And then you plot it, triangulation, so you know the point that you're at, and then you know how high it is, or low, right? That's mapping.
From that, yes, that's topography. You just described topography. Exactly. Now, to further the step to say find out if there's curvature is getting out the theodolite now. Now that I know location and elevation of those known
triangulation's already done with the theodolite, isn't it?
No.
Of course it is.
No, you do that with the total station, and it does it in this data point. That's a triangulation. You shoot to one place, you shoot to your left, you shoot to your right, and then it's back to your spot. That's a simple, easier task than
using angles.
Because you're talking about topography and a laid out triangle. When you're using a theodolite, you're using a vertical, the vertical angle. So no. You can use the horizontal angles, can't you? You don't have to use the vertical angle. Oh yeah. You're right. I'm sorry. You're right, 100%. But in that step, like I said, so those mountains, the tips of those mountains that we see in this observation. Now I'm gonna get my theodolite out, and I'm gonna measure the degrees, the angles to degree. Then I'm dropping back down to those points, not the horizon, to my points. And
why?
In that, okay.
You measure a vertical angle.
Yes.
What, for elevation?
No. Just for, I just want to know what the vertical angle is from my location to those points.
Why is that?
Because with that theodolite, you are then creating a mean line. In that mean line, it's not giving you just elevation drop. It's giving you the vertical angle to the point you're at. And when you put that data into your datum point, it is a significant, it's very clear, it's curvature. Because
No, it's a triangle, dude.
At that point, what you're then doing is no longer measuring the elevation rise and fall. You're measuring the datum points in their drop.
No. You're just measuring a triangle with an angle in between points.
Yes. And if you have, if I'm at 5,000 feet and I shoot to 0, and then I come back 500 feet closer and I shoot down and I get a 1.3.
Well,
I know the angle.
You're talking vertical angles, right? We're just talking about triangulating points, aren't we? Across the horizontal angles. Wait.
Exactly.
Yep.
And the issue what will happen there is between those triangulations and the elevation drop and rise that you got before won't match up. You will see it. You will see a significant curvature in your datum point.
No, you can't, dude. You can't measure angles of triangles and find a curve. Wouldn't have been a triangle in the first place, would it?
No, see, where are you shooting to? How do you know your elevation?
It's a you're measuring an angle.
But see, yeah, exactly. But that's exactly why I wanted to make sure I established each step that I take to do these things, because in doing that, I've laid out the options. It's not about if one of these. We're not arguing whether or not this equipment does what it does or not. I'm just explaining to you how you distinguish between the elevation drop and rise and the curvature drop that you measure with the theodolite.
Curvature drop? No, you don't do a curvature drop, mate.
Okay,
you're just measuring an angle, a horizontal angle, aren't you?
Yeah, and
it's a triangle.
And what are you referencing that horizontal angle to?
It's an angle from a triangle. You're just referencing it to a part of a triangle in order to triangulate a position. And we all know, that triangles only have 180 degrees.
And what? Okay, see, you're thinking horizontal.
No, I'm thinking about a triangle, 3 coplanar points, right?
This is exactly why when I do a topography map, there's a difference between the horizontal triangulation that you're talking about and a vertical, because the vertical
triangle doesn't have to be horizontal. No matter where a triangle is and in what orientation it is, it's always got 180
that
degrees.
Does matter. Okay. Yeah. But what we're talking about is either a horizontal or vertical. And when you're using a theodolite to do what I am describing, it is the vertical angle.
What? Why do you do vertical angles? Because that's only going to do. It's only going to do that, innit? You said you weren't doing elevation checks.
I don't know. I told you again. That's why I did this in steps. So when you sat there and you say all I did, no. I told you in step 2, I was checking my elevations and distances, but that was just one step to the next step in figuring out curvature. And in using all these 3 instruments and applying the data that you've received from that, you will see a discrepancy in between the elevation changes and the vertical angle of these data points to your location.
Yeah, see, this is where I get a problem with the vertical angle, because you're just manipulating an angle. I just see you making triangles, and at some point you're imagining, Sean, you're imagining.
Excuse me, Sean. Excuse me. Hey guys, Sean. Excuse me. No.
He's on.
You're just talking all over. Yeah. You're talking all over him. We can't hear.
Because I'm trying to say what I was going to say before.
Yes, he doesn't stop.
He
can tell what he's like. He's one of them.
What's one of them? Because I'm trying to.
One of them that just keep talking over everyone.
Oh no, yeah, I do. I am long-winded. I know that, but
okay.
I'm not one of them.
Can we get the triangle sorted, right? Because you're talking about a triangle, and then you're talking about a curvature generated from a triangle. That is the problem I'm imagining now. That it can't be done. It's impossible. But you're doing it.
Wait. So are you telling me a theodolite cannot measure a vertical angle?
I'm not saying that at all. I'm saying, how do you imagine that you are measuring angles for triangles and then generating curvature out of somewhere?
If you measure the vertical angle at different locations along your grid that you've established, the numbers will not match your grade elevation changes, and in that discrepancy, you will see, if you laid it out on a chart, you know what I'm talking about, you will see that the elevation has a curvature.
Right, well, that's why. Okay. That's why we don't measure elevation with angles. We measure first order, don't we? Differential leveling to the best point we can for the tops of mountains, and then from that point, if it's inaccessible, from that point we would use trigonometry and we would use vertical angles from known datum points plotted around the area that we can't get to, and then we would use vertical angles and triangles from that point.
You're just explaining what I explained.
Well, you seem to come up with a curvature somewhere. I'm saying we're just using triangles.
With all the steps I said, and using theodolite to get the vertical angle is exactly how you would establish that, because of the numbers that match when you do that will not match. Just like if I'm on a flat surface and I look 100 feet and I would think I'm 100 feet above that ground, well, you go another 200 feet on a flat ground, it'd be the same height. That's measuring the vertical angle.
Well, you don't do that. That's not what we're doing.
Yeah, we do.
Right.
Yeah, you do. I just established why you would do that and how you would do that, and you're just telling me we don't do that. That's impossible, because I'm definitely explaining clearly how it's used and why you do it.
Okay.
So it's not about it not being done. It's just you saying it's not done.
Okay. Well, I really want to know how you use triangles to make curve, because that would be really interesting. You didn't just explain it.
Yeah, I did. Okay. So from my known location in that observation I showed you to that second ridge of mountain to the last ridge of mountain, and if I have their known elevations, because I've already told you about those steps, and I measure the vertical angle between those 3 points, or those 2 points, because I'm on the observation side, then the numbers that I get from that will not match just the elevation changes that I've established with my datum points that I've established everywhere.
You already knew the elevations, right?
Yeah. Okay, yeah, that's already
established.
Okay,
so what is it that you think you're doing? Are you saying that the elevations have changed because looking from the top of a mountain?
No. See, no. That's the point you need to understand. When I use the theodolite to measure the vertical angle, it would appear that somehow my elevations have seemed to drop hundreds of feet. But the problem is we know that those elevations can't be changed. If you mark those elevations, they're known elevations, that's it. And when you look through the theodolite and you get your vertical angle, if you looked at where it should be, it's going to be much lower than where the theodolite has precision that elevation should be at with what you're saying.
Okay, so what do you put that down to then?
That's clearly how we establish curvature.
What do you put that down to?
That's due to curvature. It has to be.
Not just due to an optical effect that happens.
Okay, so you're saying that there's an optical illusion happening now in these optical tools.
No, I'm just saying you already know the elevations of all of the mountains. Now, they don't change. You know that also.
Absolutely,
right? They're two things that we know, right?
Yep.
Okay.
Agree on. 100%.
So going up one of those different mountains won't affect the elevation on any of the other mountains at all.
Exactly.
Okay.
Exactly. So when you get that vertical angle, and just throwing numbers, so I'm not looking at numbers. If you measure your vertical angle is at 2%, whatever, and at 2%, 1,000 feet lower isn't at 1,000.
Sorry, what's a 2%
appear
angle?
It would appear in that optic.
What's a 2% angle, Sean, please?
Actual grade is 1,000 foot lower.
What's 2%? I'm not up to date with all of your surveying terms.
It'd be the drop. I'm just throwing. I said it. These are just throwing out numbers for an example.
Oh, so just throwing out a percentage. Nice.
From where
like
yeah. So from where I'm at, there's a 2% fall to a datum point.
2%. You know, that sounds like rise over run sort of.
No, remember
a grade, is it?
We're just talking about this triangle, the vertical angle.
Yeah, but so a 2% is like a grade, isn't it? That's an incline.
Yes. 100%. The grade, the slope of my the optic, the slope of the optic to a point is what we're talking about.
Rise over run.
So what happens is
rise over run, right?
I'm
just checking that we're doing the same surveying.
Yes.
Yeah, because I did a bit of old school stuff, so I need to be kept up to date. Go over this. Wait a minute. Rise over run. Just keep us up to date. Rise over run. That's distance. No, wait a minute. Height over the distance to give you that grade slope.
Yes, distance over elevation. So a quick, easy way for people to understand.
Like a horizontal distance and a vertical height, right?
Yeah. So you may know this, but for people who don't, for 1 foot of rise to 1 foot of distance is a 1-to-1, 2-to-1, 3-to-1, and so on and so on. But it's in foot if you want to get real technical. Yes. So basically, you're measuring that slope to your point. And say we know at 5,000 feet, my 2% at 10 miles should be 2.5%. But when I look through my theodolite and I measure it, it's 2%. Then I know there's something is wrong. There's a discrepancy in my reading, because I know it should be at 2.5, but I got it at 2%.
So what do you do? What do you do when you find that out?
That's how we know there's curvature.
Do you move the mountain or something? What happens?
You measure the actual drop. Slope.
Yeah, but you already, like we went through this at the beginning. You already know the elevation. You already know where the peaks of the mountains are.
I'm happy you're saying that. So when I look
so you go up to the top of one of the mountains and go, hey, that doesn't look like it's in the right place. What do you do at that point?
Yes. So if one mountain is at 1,000 foot, we know it doesn't change. The next mountain's 1,000 foot, and we know it doesn't change.
Yeah.
But that second mountain in the optics is like 1,000 feet lower. That's how you know there's curvature, because we know that both those 2 points are at 1,000. We know those 2 points are at 1,000 foot elevation, and that can't change. But if that second mountain is lower in elevation and lower in my optics for that slope to that point, then I know it's curvature, because it can't be 1,000 foot and be lower, have a lower angle than the first mountain. That's it.
You have a very interesting way of going about this surveying. Is it surveying?
Absolutely.
Okay. Because you already know that the mountains are where they are and how high they are. So just because you go up a mountain and look at another one and go, hey, that mountain doesn't look like it's...
You're right. I told you, I started by saying I could easily just look at a GPS map and tell me each elevation of each mountain around my area. But I decided, because I've done it for a long time, develop topo map. I don't get on a GPS and go, that mountain's 1,000 foot, that mountain. No, because in estimating and planning a job site, the cut and fill, I have to basically lay out a whole topographical map of what is planned out to be done.
Let's keep down on that, like on the ground sort of stuff, because that's what we're all familiar with. There's no need to go to the tops of mountains to explain this sort of stuff.
But you see, that's the easiest way if you want to establish is there curvature or not. But if you want to go back to the ground, we can still do this the same way. It's all the same. The only difference I gave is I did it in the mountains because it's that much easier to establish what's happening.
Well, see,
than doing it on a flat ground.
when we did this,
on
Sean,
sea level. Yeah,
I mean,
so-
spot on. We initially came to it at first, and we said, how would you find curvature? Where would be the best place for you to find curvature? Well, obviously mountains go up and down. You can see that curvature, right? So that wouldn't really be hard to do that because we can measure the elevation changes of the land, right? So there's curvature, there's lumps and bumps everywhere, right?
Everywhere. You don't
okay.
have to do it on the mountain.
Okay.
That's just a place
So
outside
when we
plain
said where's the best place to look for the curvature that you think we're talking about, because what we are actually talking about, Sean, is the curvature of the level, isn't it? When we say that level is
I'm
a
sorry.
straight line on a
I'm
horizontal plane, that
Yes, you
is
are
that
correct.
what
Yes.
you are talking about, the curvature of the level?
Yes. Yep, because level is reference to what?
Pardon?
So when we're talking level, say if I'm leveling out a shelf or I'm leveling out a parking lot, doesn't matter.
So you're
What is it-
leveling
what
out
is
the
that?
land. Yeah.
Yeah. But what is that horizontal referencing? What is it what is it horizontal to?
It's what the water does. That gives you
Okay, but okay.
what horizontal
but
is.
what is
Equilibrium.
If I'm doing
A natural
doing a
state of
shelf-
balance.
Yeah, I understand that. If I'm doing a shelf or a parking lot that I want to be level, what is that level reference to?
Horizontal.
What is level water reference to?
A balance, neither higher nor lower, even.
A balance of what?
Equilibrium.
Okay, so then what's the equilibrium of dirt when I do it, or the shelf when I do it? What is it referencing? What is that reference to?
A horizontal position, an equilibrium,
What
a state where nothing is neither higher nor lower at either end, or in the middle.
In reference to what? What are you referencing when you're doing this?
The horizon. Okay.
No. Okay.
Yeah.
So when you
Everything's
level a shelf-
referenced to the horizon. Did you not know?
When you level a shelf, or you grade a parking lot, or you measure level water, you have to have a horizon to
No.
level, to reference
See,
it?
this is where horizontal comes in. It's the totality of the horizons. Horizontal, right? It's all of the horizons together, because as we know, horizontals are parallel to the plane of the horizon. Right? So that's what we're referencing when we say, or when I say particularly, I guess I can speak for quite a few people here, that level is horizontal, right? It's you are referencing something to that equilibrium state. Now, that equilibrium state is referenced by the water. The water goes into that state. So you could say that the water, causes that state of horizontality.
Okay. What makes the water horizontal? What is it see, here's the thing. There is obviously a simple answer. I know it, but you don't believe it is. So I'm asking you, what is horizontal? When you're standing in one spot and you use a water level with a little bubble in it, what is it referencing to be horizontal?
Perpendicular. Perpendicular.
You're just saying words. I'm asking you what references it.
I'm
What
giving
is it
you
a reference
geometric
to?
words so you can be absolutely sure that what I'm talking about. Right? There's no qualms about it. There's no niggles. You don't have to worry about it.
You're just saying words that are different, that say horizontal, just differently. But when I'm asking
Perpendicular.
you, what?
Yeah? Is that funny? It's a funny word. Is it the dick bit in it?
No, but okay. I have to say it because this is the only way I guess I can make it clear to the world. Okay, when I hold the level, it has a little bubble in it.
Are you streaming this?
Or better yet, a plumb bob.
Oh, yeah, plumb bob.
That horizontal, that vertical all these things are referenced to gravity in the center of our mass.
What?
So at that point,
No. Vertical is just.
Yeah, that's exactly how it works. That's why when you get on a mountain, it doesn't point at the same slope as the mountain does, and it goes point down.
Yeah, vertical. Yeah, I understand what vertical is.
Okay, but before we veer from the topic, what is your horizontal in reference to?
Perpendicular. It's perpendicular to a plumb bob, isn't it? Or vertical. It depends which you want to talk to.
Perpendicular in reference to?
It's perpendicular. Do you understand what perpendicular means?
Yeah.
The term.
That's what I'm asking you.
Yeah.
What is making it perpendicular happen?
Geometry makes perpendicular.
Why doesn't it veer to the side a little bit? Why isn't horizontal kind of sideways a little bit?
Perpendicular. It's a geometric term, right? It's not dictated by either one, but once you have a straight line or a right line, depending on what you want to call it, then you automatically generate its perpendicular. It's a geometric term. It means being at right angles too. Yeah? Has he gone? He still is, Sean. It just means at right angles too. And that's a very definite geometric term. Yes.
So to apply something that is level, horizontal, to apply something that is perpendicular, vertical, what do you reference to know that those things aren't just sideways?
Well, you have a plumb bob for the vertical, and you have a tool called a level for the horizontal. Okay. Two totally separate tools for two totally separate jobs.
Yes, you're right, 100%. What do those two tools reference to give you those angles?
Well, I would say, again, the plane of the horizon. That's your reference. They're both right lines, perpendicular to each other.
If you're in a mountain, in a valley, what do those tools still work?
Absolutely. They work anywhere, don't they?
So what are they in reference to? What makes it level and not sideways? What makes it perpendicular and not kind of sitting off, kind of leaning a little bit?
Well, what makes water level? Is that what you're asking?
I'm asking you. No, we're talking the geometry, that horizontal and the perpendicular.
Horizontal is by a water level would be the tool that I would say in nature that you could use at any time, right? Because we know how water flows. It goes from a higher elevation to a lower elevation.
I have a better way. So I have a plumb bob. For me, and how I
perpendicular
to be, and how I understand things to be. If I have the string in my hand and the plumb bob in my hand, and I just let the plumb bob and hold the string, and I let the plumb bob go, I understand that the plumb bob drops straight down and gives me a straight perpendicular line due to gravity.
Whoa! You just said straight perpendicular line. What do you mean by that?
Yeah, the string.
Plumb bob it's a straight vertical line.
Yeah.
And because it's straight, it has a perpendicular, and that perpendicular is at right angles and is also a straight line. Yes.
Yeah. But see,
okay.
Here's the problem. Why doesn't the plumb bob go sideways?
Because it's hanging vertically. It is a perpendicular. It is a right line.
Why is it hanging?
Why is it hanging? Because that's the tool. That's what it does. That's the job. It is a plumb bob. Okay. It is a weight on the end of a string.
Why doesn't it go sideways?
It's vertical.
Okay, but why doesn't it go sideways? Why does it go straight down?
Because it's a plumb bob, and it is a tool for establishing a vertical frame of reference.
Okay, would I put helium in a balloon and expect it to do the same thing as this plumb bob?
It would go in the opposite direction along the vertical, wouldn't it? The same vertical.
Okay. What is making these two objects affected in the way they do?
The vertical distance away from equilibrium.
Okay.
Oh, that was good, wasn't it?
Okay. Okay, just to make it clear, I've asked you what makes these things drop and what makes these things go up, and you told me it's vertical distance between. What makes these effects happen?
I'll say it again. It's a vertical distance away from its equilibrium, barring any other external forces, obviously, like wind.
What is it equal to? What is the equilibrium that it is that is affecting these objects?
An equilibrium is where it wants to be in a state of balance. Have you heard of it?
But, yeah, oh, absolutely. But something has to make this happen, doesn't it? It doesn't just happen.
I don't know. Wait,
It's not
go on.
magic. We know that. We know it's not magic.
Oh, not magic. Go on then.
Okay, well, if we're discussing this, then for me, in my understanding of it, gravity and the buoyant force explain why these two objects act the way they do.
Act perpendicularly, right? It acts perpendicularly to the surface, does it?
Yeah, that's crazy, right?
Well, yeah, because perpendicular is two straight lines. So, yeah, that would be crazy for you to say it's perpendicular. It's not crazy for me because I've got vertical and horizontal. That's fine.
Yeah, that's what I was asking though. Why doesn't the plumb bob or the balloon go sideways?
Why would it want to?
Why not? I mean, nothing's just
you want it to go sideways, do you?
Nothing's forcing it
to
go up or down.
Do you want it to go sideways?
Is anything forcing these
Sean,
objects to go down and up?
do you want a plumb bob to go sideways?
I wish. That'd be fucking awesome. I'm sorry, I don't know if you guys cussed. My bad. I didn't mean to. That'd be awesome.
Right. So there's no way that you could think that one person's vertical could be another person's horizontal, right?
Oh, absolutely not. That's impossible.
Yeah.
I mean, it's not
wow.
impossible. It's just,
Imagine that.
Okay. So what you're telling me is a force has nothing to do with a plumb bob going down and a balloon going up. Am I correct?
What? No. You know what a plumb bob is? It's a tool for making a vertical frame of reference, right?
Yeah.
And a helium balloon isn't a plumb bob.
I do want to say again. I actually got to go. I do want to say this though, Bev.
Did somebody call you off? Was it the vertical and horizontal thing?
My handlers, they DM'd me. We're like, shut the fuck.
Oh yeah, I bet.
No, I gotta go back to work.
Yeah.
But I do actually enjoy conversations with you.
Sweet.
And I do appreciate the respectfulness of it. So I just wanted to say thank you for another good conversation.
Yeah. Thanks for popping round anytime again, Sean.
Absolutely.
Please come back.
My friend.
I'll dig that meme out for you. Go on.
Before you go, Sean, can you you seem to know a bit about the use of levels, auto levels, and that. Is there a maximum kind of operational distance for an auto level? For accuracy purposes, I mean.
Yeah. I wouldn't go past, for me, I wouldn't do a job that has 1,000 feet plus in distance. I'd break it up into sections for it. The fraction of that laser is so fucking... I don't know if...
Laser?
Wait. Bev, do you guys cuss?
Auto level.
I know, hang on, but Bev, do you guys cuss here?
No lasers.
Yeah, we try not to, but I mean...
Okay.
If it's educationally useful, then...
No, I'm trying to hold back, and that's why I wanted to make sure, so now I can make sure I don't. Sorry. With an auto level, what you're going to start getting is refracted optics. Like, you'll start seeing wavy lines, things blurry at a certain distance.
So, operational distance, Sean, that's all I'm asking about.
Yeah.
For accuracy.
If I'm using one, I would use it only at 1,000 feet and less.
1,000 feet.
About 333 meters.
Yeah. It's literally I wouldn't use that for a long distance.
Would that be like 32 times optics or less?
It would depend on the tool you're using. They're different.
So the less powerful the optics, the shorter you would have to make that distance, yeah?
Yeah, if you go to Home Depot and buy an auto level, like, one of those $30 auto levels, After
No, I
100
wouldn't waste my money.
Yeah, but at 100 feet, they're useless. You know what I mean? So it's kind of like in that situation.
So you
talking
would
coincidence bubble levels then, are you? Google it quick.
Yeah, you would comfortably use an auto level up to 1,000 feet.
Yeah, in the times I've used them for like grade checking or doing retaining wall, 1,000 feet at the most, from in my experiences.
Right, and what use is an auto level without a story pole? In your opinion, what would you say?
Oh no, that's what you'd want to use. A linker rod. I call it a linker rod. For everyone, a very large measuring stick.
Yeah. Adjustable. It's like telescopic. Yeah, it'll go up.
Exactly. Wonderful thing. Yeah.
Yeah. So would you say that what would you say about somebody who uses an auto level without a story pole? That's pretty useless, isn't it?
I mean, unless you want to walk to a point and put the elevations on a point and look for that. I mean, but then again, you're just making one, right?
And so 1,000 feet is nowhere near 16 miles, is it?
No, for an auto level. For an auto level, okay. So, and I'm pretty sure you're referencing B-ball or life preserve. I'm not 100%, but in all aspects of it, if you're using an auto level, you're not trying to get a super far shot. Depending on the one you have, if it's less than $1,000, it's not. A mile is pointless. Don't even try. If you don't have a known height of what you're looking at, it's useless. It's a cheap, basic theodolite. It does what a theodolite does, but it has none of the measurement tools on a theodolite, basically. Best way to say it, theodolite is an auto level on steroids. And even with a theodolite, you need to know the height and elevation of whatever you're looking at. So, I mean, again, knowing that your height is important. And because you can't look far with an auto level like that, it's easier to use a pole to tell you the height.
And the further out your observation, the more subject to atmospheric conditions your observation.
Absolutely.
Okay. So a 16-mile observation over water is absolutely fucking pointless.
With an auto level, yeah. And I get what B-ball's doing, but if we're talking just basic looking out with an auto level, it's pretty pointless. You need to get some type of...
So basically, B-ball's observations are fucking useless.
What about with a theodolite over water?
Yeah, theodolite over. That's what I'm trying to explain. The reason why it's not okay, you can use an auto level looking over water at the horizon, but it's not going to give you any accurate measurement. All you can really say is that my eye level is higher than the water. That's it. For me, that's good evidence already. But in the understanding of what's happening in this community, that's what needs to be done. You need to know that vertical drop that we were talking about. And that's what a theodolite does. If you know, say, again, like you were saying about the story pole, the large measuring pole. If you had someone at your optical horizon with a measuring pole and you knew the distance to that person, then an auto level works. But again, then you need someone else. You need another reference frame to make that point. That's why total stations are awesome, because you're able to beam back what you're doing. It's a different situation. But I actually, guys, I got to go. I'm about 5 minutes late already. But Bev, I'll come back and talk about this stuff. It's fun. I like doing it.
Sweet.
And as long as everyone stays cool like Bev has, I'm cool to be here. So I'll talk to you soon.
All right. Sweet.
Cheers, Sean.
What you get? Good. What did you get? I had to go make me brew at the end.
But he contradicted himself because he said earlier he was looking at a mountain 10 miles away and talking about a 2% drop.
Yeah. Yeah, it's a theodolite. What happened? Because I had to go and make a brew. I asked about the I think DP was asking him about the auto level, and he said you can't look over water. And then I asked about a theodolite. What did he say about the theodolite over water? Is it better? Did he say it was better, or he could do that? Did he obfuscate?
Oh, he just talked about the same thing again, where he said the you have to know the known height of what you're looking at. That it doesn't really show much because you're looking over such a long distance.
Yeah.
But for him, it was good enough evidence.
It's Mobius here, because see, I was helping you there, Mobius. There's a guy who's got a video with an auto level and a theodolite, puts them next to each other, and he looks out across water with them side by. He even measures the height of both of them. I don't know why he does that, but he does.
It's the same optics, though, isn't it? It's just 30.
I think
they don't
so.
go over 32 times.
Yeah, and he got different heights, and he said he'd expect to see different heights. So I bet Sean would expect to see different heights with him too, because it seems like he thinks the auto level can't do it, whereas the theodolite can. But they both have 32 times optics, so.
I don't think this guy's for real, because he was talking about checking grade for like a parking lot or a footer. He kept talking. I think he was just talking about a laser transit.
I think
that's
so.
just. And then because earlier he said water level, talking about the bubble, and that's spirit level. I don't think this guy's. Yeah.
No, it's Sean G. He's been saying he's a surveyor for a while, and he's took a year out, and now he's come back, and it sounds like he's done a little bit of looking over some. He calls them topo maps. I mean, somebody's just told him to say that. It's just topographical map. I mean, we all know what a topographical map looks like.
The way he was talking to me, it sounds like he's just your average Joe, works on a construction site, uses a transit that beeps when you move the pole.
Yeah. Yeah, he
that's my opinion.
Got a few things wrong, but I think we're training him, aren't we?
Yeah.
This is high level stuff for the Glarper. The studying Glarper. He'll come and find out what it's like in reality, and then see what he's got to fix in his argument, because no doubt he'll be able to talk to the flirts. Might sound a bit impressive to the flirts. Well,
that was interesting.
I got that saved anyway at 50.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.